Welcome to the Junior Dev Canberra event. We are fully online for now, so just grab some snacks, relax, and enjoy the stream.
We would like to begin by acknowledging and celebrating the Ngunnawal and Ngambri peoples on whose land we meet and work. We wish to acknowledge their culture and the contribution they make to this region, and we pay our respects to their elders past, present, and future.
During the event, if you have any questions, please use the Slido link to post your questions, and our speakers will be happy to answer the questions at the end of their talk.
Good evening, everyone. I'm Aimn, and I'm a graduate developer at Xero. My talk today is about solid principles and why you've probably never heard of them. I will base my talk on the assumption that you're new to programming principles and you haven't had much exposure to solid principles before. And you have recently started your development career. The reason why I do this is because there's heaps of resources on the internet about solid that you can watch hundreds of videos and do so many other things. But if I compare myself to where I was 6 months ago, I did not know what I needed to learn to fully implement solid. So I'm going to share a little bit of introduction with you about solid. My talk today will basically cover the introduction about solid, its advantages, disadvantages, where you should use them and why. Because if you haven't heard of solid yet, you will hear about it very soon as you step into the job market. Because these principles are used in almost every organization when you're writing production code. I'm going to explain each one of the principles at a time, and then we can take questions at the end. And I will not cover the exact implementation of each concept because there is no exact implementation. This is the implementation will heavily depend on the project that you work on. So I will just give you a brief overview and the resources. The aim of this presentation is to make you interested in this topic and to help you identify what you don't know about solid. So this way, when you have to learn it, you know what areas you need to focus on. So why did I assume you've probably never heard of solid? First and foremost, solid, like I said before, is used in large code bases, mainly in organizations that write production code. So when I was in uni, the code that I wrote was just a few files long, and its lifespan was just a few weeks until my professor approved of it. So this is why we never use solid. This is why we never taught solid at university. And then at unis or at the start of your career, not many people write code that's used by other people. So for example, the code that you write at uni, the methods that you write are only ever used by you or one of your other classmates. But when you work for an organization, the code that you write might be used by hundreds of other people. It might be used at hundreds of other places. So we need to write code that is good quality and that follows solid principles. Then the solutions that you write will have a longer lifespan. The lifespan of your uni projects or the side projects that you have might only be a few weeks, but you implement solid principles when your solutions have longer lifespan, for example, 6 months, a year, 2 years, and when you continuously have to update your solution. Basically, solid makes your future life easier, and it is extremely helpful for writing unit tests and integration tests. I cannot imagine writing unit tests without solid. All right, let's dive into this. What is solid? The S in the solid principles stands for single responsibility. What this means is a class can only have one responsibility and only one reason to change. Some people implement this down to a method level as well, but for the sake of simplicity, we will only talk about classes here. So the single responsibility principle states that a class can only have one responsibility and only one reason to change. What does that mean? Let's look at an example. So if you look at this class, let's not talk about what this class actually does and what this program is about. If you just look at the first few lines of code in this class, notice how in the on line 13, the line that's highlighted, there is a message. Now, there's some sort of message that the class displays. Then further down, the next line of code is we're instantiating a object of class person. Then we're triggering the user to enter some information, and then we're trying to read from that information. So if you just look at this class, it's doing a bunch of different stuff. So this class right here does not follow solid single responsibility principle. In this next slide here, notice how we have separated messages into a different class. Now this class here deals solely with messages. Now it has a function for welcome message, a different method for end application. So this way, all your messages are there in a separate class. Now, can we go a slide back, please? So notice how in this previous slide, we have so many different things happening in a single class. But in this next one, we have separated out messages completely. So we know that the message class is separate. Whatever changes we make to the message class, they remain separate. And this is how we follow the S in the single responsibility principle. Now you might ask, why do we need to follow the S? Why do we have single responsibility principle? So one of the biggest advantages is that it is easier to navigate through your code. Now, why would you want to do that? Because you're probably not the only developer who's going to work on that code. There'll be heaps of other developers working on your code, and you want your code, you want the code that you write, you want the other developers to easily navigate through the code that you write. Obviously, it would depend on heaps of other things such as folder structures and how you arrange your classes and all of that. But having separate classes and naming them appropriately is the first most important point in making your code easy to navigate through. So in the example in the previous slide that we looked at, there's a separate class now for messages. So when a developer comes and takes a look at your code, they know that all the messages will be in the message class. They don't need to keep looking round and round for different for places where messages are. They don't have to do a global search, a shift control F, and all of those different things. It's very neatly written code. The next advantage is that it is easier to read and understand the code in the class. This is because the classes are more neatly arranged. Ties into the previous point, the thing that I talked about before. The next advantage is that it is a lot easier to debug. So you have a starting point, you look at the classes, you see they're neatly arranged. When you debug, it's easier to follow through the code. You know, whenever a message will be displayed, your code will hit a breakpoint in the message class. So it's a lot easier to follow through the code and write that. Next is that changes need to be made at one place only. So if we look at at our slide in the first example, when a new developer comes in and he's been told to update the welcome message, they don't know where the welcome message is. How are they supposed to find it, and how do they know where to make the change and what change to make? But if you have a separate class, they can just come in, make the change, and it would be at a single place. Then there are small methods in classes, and it makes a lot easier to add changes and locate the areas where we need to make the change. Again, all these points tie in together. And among many other advantages, another one is that it is a lot harder to break the entire application with a few changes. So if we go back to the slide, the example, the first example, sorry. Yep. So if we go back to this, if you make a silly mistake in this when you're trying to update it, there is a chance that your entire application blows up because your entire application is dependent on one single class. But in the next example, if you have a look, if you make any silly mistakes to this, there is a very low likelihood of breaking the entire application. You might break all the messages that are displayed, but that's the worst that can happen in this case. And these are a few reasons why we use single responsibility principle. Now, the next principle in Solid, the O stands for open close. It's a very simple principle, very easy to use. Open close principle states that your code should be open for extension and closed for modification. What that essentially means is, If you have a piece of code that works all fine, you should not go into it and modify it to potentially break it. If you want to make changes to it, you should initially design your code in such a way that it is easier to extend the code. So if you look at the example, this is another method. This is another program. It does stuff. But if you just look at the first few lines of it, in the main method, there is a list for person model, which takes in some applicants. Let's just assume this is a job application software. And it takes in three objects, takes in their first name and last name for person model. Now, it's all well and good. We don't have the implementation for it, but just for the sake of understanding, let's assume that the person model has 3 properties in it. Let's say it has first name, last name, and email address. It's all good until your manager comes to you and tells you to extend the software, to update it, so that to accept a new application for executives maybe, and add a per hour rate for all those executives, or something like this. What do you do then? You go into the person model and make the changes? Person model works fine. Why would you want to go in there and make changes? So this is why we follow the open close principle. Again, there are heaps of ways of following the open close principle, but just in this next slide, I have created an interface for the application model. So this is the interface segregation principle. We will talk about it a little bit later. That's the I in solid. But I am assuming that you would be familiar with interfaces and how we use them. So we've created an interface for applicant model, and then we have created 3 concrete classes that implement that interface. So we have a person model, a manager model, and an executive model. So what we've done is now it's by use of interface, by following the open close principle, it's a lot easier for us to extend or to add more properties to each one of the classes without breaking the code itself. So now, why do we use the open close principle? First and most important, it gives you the flexibility to add changes wherever you want. So for example, in the previous example, if you wanted to add changes to the person model, then we follow the open close principle. It's a lot easier for us to add changes to it, to modify it without the worry of breaking the code that we know works fine. So that ties into the second advantage that we have. You don't have to change working code. So if you've unit tested, if you've manually tested a piece of code and you're 100% sure it works, what is the point of changing it? Why take the risk to change it? Just follow the open close principle and extend that code. Then it better implements single responsibility. So if we go back to the example, please. Sorry, just slide back. Another one back, please. Yeah. So if we go into there, notice how now we have a person model, a manager model, and an executive model. This means that we are following the single responsibility principle here. The only reason why we would want to go into person model and change the person model would be if we need to make any changes to the person itself. So if we want to add some more properties other than first name, last name, and email address. So this helps you follow the open close principle. But excuse me. But again, to implement it better, I suggest that there's heaps of resources on the internet. There's this guy called Tim Corey who makes amazing videos, and that is where I've got most of this code from. So I suggest you look into that, and I do have resources. I do have links to his resources at the end of this presentation. So these are we're just talking about advantages, so I won't go further into the details of this. All right. So the last advantage of using, not last, there are a lot more, but what I want to talk about last is open close principle prevents tight coupling, and it makes it easier to make changes. Now, I just added the definition for tight coupling here, but I hope I'm insulting your intelligence here. So tight coupling is basically components, means that components strongly depend on each other. And this is something that we don't want in our application, because if components strongly depend on each other, if you make changes to one component, the other one breaks, and we don't want that to happen. Again, a bit more detail coming on in the next principle. So the next one, the L in solid, stands for Liskov substitution principle. And if you look around on the internet, the definition for this principle looks a bit hard and a bit confusing, but it's actually very simple. So what it means is, this principle defines that objects of a superclass shall be replaceable with objects of its subclasses without breaking the application. Now, what are subclasses and superclasses? Again, I just added in the definition here, so it's easier to understand for junior developers, but I'm assuming you would know this. A superclass is the class from which many subclasses may be created. The subclasses inherit the characteristics of a superclass. The superclass is also known as the parent class or base class. So an example of a superclass would be vehicle, and an example of a subclass would be car. So there are many different types of vehicles. You can have SUVs, cars, sedans, trucks, all these different types. But so that's the superclass, and subclass are all these smaller classes that depend on the superclass. Yep, next one please. And again, so if you just look at the example for this, so if you look in the code, there's an employee object. So you see employee emp, that's the object, and we instantiate it to a new employee. So what basically the Liskov substitution principle means is that you should essentially be able to replace the new employee on the right hand side of the statement to anything that's a subclass of this employee. So that might be, I don't know, a manager, it could be an executive, anything of that sort. So if you look at this next slide, we have now replaced employee object. We have now replaced employee with manager. And if this application follows the Liskov substitution principle, this shouldn't break. So what this means is the manager object should have an implementation of the first name property, last name property, assigned manager function, and calculate per hour rate function. Now, the implementation of it, the actual implementation of the functions here, the assigned manager function and calculate per hour rate function, might be very different to the employee to how the employee class implemented it. But that's not the point. The point is they have an implementation here that is not entirely different to the employee class implementation. And that is what the Liskov substitution principle expects us to do. Now, that sounds a bit hard. Why would you do that? Let's have a look. Actually, before we do that, so let's have a look at a few terms that you might come across when you do a bit more research into this, and a few rules. So there are 4 rules to following the Liskov substitution principle. The first one is covariance. This means that return type of method cannot change when you're implementing a method. So if you just go back to the previous slide really quickly. Yep. So in this example, in the implementation of the assigned manager method in the manager class, surely the result might be different, but the return type cannot be different. For example, if the assigned manager class in the assigned manager method in the employee class returns an integer, the same method in the manager class cannot return a double. It's very simple. Return types of the two classes of the methods of the same method in the two classes cannot be different. They have to be same. If we go to the next slide, the next point is countervariance. Countervariance means that the input type of a method cannot change when you're implementing a method. So again, if we go to the assigned manager class, the assigned manager method in the employee class, if this method takes in integer, for example, in the employee class, it cannot take in string in the manager class, because you essentially should be able to replace the two. And if we are not following the covariance and countervariance rules, we would not be able to replace the two. The next one is postcondition. Postcondition means that superclasses cannot have strict parameters of values they can accept if this is not implemented in the subclass. So for example, in the superclass, in the employee class, we say that the the maximum per hour rate can be 100, and for anything more than that, throw an exception. But in the manager class, we don't set any such restriction. We let it throw. We let the value be calculated to over 100 to maybe 200. So this would be not following the post condition, and hence we will not be following the list of substitution principle. And the final condition is the precondition. This means that you cannot add checks in subclasses if they don't exist in superclasses. So it's just the other way around. So again, if in the manager class, in one method, if you're throwing an exception, you need to throw the same exception for similar logic in the employee class as well. That is our superclass in this case. So these are just 4 things that you might come across, and I felt that they sound a lot harder when you're looking at them on the internet, and a lot easier if you just look at these simple definitions. So nothing too hard, just basic general knowledge should make sense. All right. So why use the Liskov substitution principle? We use Liskov substitution principle because it gives us the flexibility to swap items for their parent implementations without breaking the application. So, and you would have seen quite a few examples of this in the code that you write. For example, if we look at the next slide, so if you look at this one, IEnumerable class is superclass, and list class is a subclass. So this is a very common line of code that you would have seen in a few different places. So this is just one example of why Liskov substitution principle is important. But again, both of these classes are written by Microsoft. You don't have to write them. This is just a very good example of where Liskov substitution principle is followed in C#. So in the next slide, I've just tried to remove the wiggly line under a T, change it to a string. All right, the next one. I in solid stands for interface segregation principle. I promise you the name sounds hard. It's not really hard. What does this mean? So the definition for this, if we go to the next slide, please, is that a client should not be forced to depend on interfaces they don't use. What does that mean? Let's have a look. So if you look at this is an interface for a iLibrary item. This might be a software that is used in libraries in the ACT. So this is an interface for a library item. We would assume that all library items should have more or less the same properties. So this iLibrary item has author, borrow date, borrower, checkout duration in days, and so on and so forth. All of these properties would apply to a book class. So imagine if a book class implemented this iLibrary item, it would be all good. But because we follow the open close principle, and we have to write code that is extendable and that we don't have to modify. Imagine if your manager comes to you and tells you to add another item. Now your library also has audiobooks or DVDs in it. Let's just take the example of DVDs. A DVD does not have an author. It would have a borrow date. It would have a borrower. It would have a library ID. It's very unlikely for a DVD to have pages in it. It would have a title. So notice how a DVD does not have an author and it does not have pages in it, which means that if you implement this class, if you implement this interface for a DVD class, that would mean that you are inheriting two properties. You're trying to implement them, but you're not using them. So this is against the interface segregation principle. Wow, what's the resolution of this? There are a few different things you can do. But just in the next slide, I've created a class diagram. So excuse me if this is not all good, because I haven't created class diagrams since I left uni. That's about a year ago. So what I've done in this is we've created 3 different interfaces now. So we've created a iLibrary item, which has borrow date, borrower, checkout, duration days, title, and library ID. So these are the things that every item in the library should have. If it's a DVD, if it's an audiobook, if it's a magazine, all of them would have these common properties. Then there's an iBook item. So the properties in this are just restricted to the book item. So author and pages would only be in the book item. Presumably, they could be in the magazine, but we're just talking about book and DVD here in this example. And if you look at the iDVD item, I have misspelled item in this. There's length in minutes, there's director, and there's genre. So what we're doing is the book class is implementing iBook item and iLibrary item, and the DVD class is implementing iLibrary item and iDVD item. So what this allows you to do is that it allows you to create classes that do not implement properties they don't use. And this is the interface segregation principle. Now, why would you use the interface segregation principle? One very important thing, a very important advantage that's been common throughout all the other principles, is that one change does not blow up everything else. So imagine if you had to add another property to the iBook interface, to the book class. What you would do is you would just add that property to the iBook interface and just go from there. So your one change cannot affect everything else. Then it gives you the flexibility to extend the project very easily, similar to the previous advantages that we talked about for the previous principles. And finally, classes aren't burdened with extra code that make them harder to understand and unnecessarily complicated. Now, this is something that we don't understand the importance of as uni students, and probably not in our early stages of our career. But as we progress in our career, we realize that the code that we write is used by many other developers. So if we're writing classes that are unnecessarily complicated, it just makes it harder for other people to understand what you're doing. So interface segregation principle is very helpful in that regard. Now, the final principle, dependency inversion. So dependency injection and dependency inversion are very commonly confused with the two, just like I did it. Dependency inversion is the principle. Dependency injection is the implementation of the principle. All right. What is the dependency inversion principle? The dependency inversion principle states that high-level modules should not depend on low-level modules. Instead, both of them should depend on abstractions, and those abstractions should not depend on details. There's a lot of buzzwords in there, but nothing to worry about. What are high-level modules again? High-level modules, the class which is performing a task with the help of another class. What are low-level modules? The class which receives commands or help high-level classes to perform a task. Super simple. So, when you normally write code, high-level modules depend on low-level modules to do things for them. This should not happen. So this is where the name comes from. We are inverting the dependency. So because high-level modules are dependent on low-level modules, we are inverting it, and now both of them are dependent on abstractions. This can be done in a few different ways. Again, we'll not deep dive into the implementation. We'll just look at an example to understand the principle itself a bit better. So if you look at this this program here, there's a class for person. It instantiates a new object, owner for person, and then there's a chore class. And if you look at it on line 25, line 25, notice how owner from the person class is used by the chore class, and it's directly dependent on it. Which would mean that if I make any change to the person class, the owner property for the chore class could break. Now, in our enterprise application, person class could be managed by a different team in a different continent, and chore class could be managed by a different team. And the changes that the team who uses person class makes, they might not be able to communicate every single change they make to their class to this other team. So this is where dependency inversion principle comes into play. We don't want high level modules to be dependent on low level modules. So if you look at this is why we create interfaces. Although interfaces is just one example of how we can do it, there are tons of other ways for dependency inversion. Again, there's no perfect implementation. The more you look into it, the more you will understand how it works. So if you look at it now there's an interface. There's an iPerson interface, and there's an iChore interface. So any changes that you make will be based on these. So both of these high level and low level modules are now dependent on these abstractions. And these abstractions, the iPerson interface and the iChore interface, do not have an implementation. And in the next slide, I've just given you a bit more detail. This is one of the ways for implementing dependency inversion. What I've done is I've separated out where I initiate all the I've separated out where I instantiate all the objects for all the classes. So if you just call the create person interface, it would return new person to you. A good way to do this is dependency injection, but to avoid confusion here, I did not use dependency injection. They're just named. They're both acronyms are DI. That's just to confuse you because they hate you probably. Anyway, why use dependency inversion? One of the most important things, if you change the application in one place, and if you change one thing, everything will follow through. So you don't need to go to different places and make changes there. So going back to our person and chore example, if you make any changes to the person class, because they all follow abstractions, they followed interfaces in our last example, we will not have to make changes to every single class. That is dependent on our all the high level modules that are dependent on the low level modules. We have a disconnected application. The application is modular. It's not a monolith. So everything is not interconnected. Everything's not dependent on each other. Everything's separated. So you can make changes to separate places. You can add, remove classes without breaking things. Then you're set up for dependency injection, which is an implementation of dependency inversion. You can also inject dependencies from external sources. So you can use NuGet packages, for example, get dependencies from there. And one of the biggest advantages of using dependency inversion is unit testing. So it allows you to use mocks. You don't have to instantiate everything when you're unit testing anything. You can just use mocks and mock everything up using dependency inversion. And finally, again, the advantage that we talked about a bit before for open close principle as well. Dependency inversion allows loose coupling, which means it's easier to. I've written break here, but it doesn't mean breaking the application. It means the application is modular. It's not a monolith. It's easier to test, and you can edit each piece by piece without actually breaking the application. In the final slide, I just have just this resource here that I found very helpful when I started learning Solid. And all the code that I've used comes from Tim Corey's videos and his examples. So you will find the entire code there if you want to have a look. If you have any questions that you feel can be answered by looking at the code. So all the code is there, the starter code and the final code in his blog. The videos are a bit long, but I do suggest if you want to develop a solid understanding for Solid, I suggest that you have a look at those videos. And that's it. That is Solid. If you have any questions, please let me know. Oh, we have questions. All right. All right. So the first question was, hi, Aimn, since you mentioned sometimes school don't teach us solid, did you also find out something new like this you had to learn for your job? Thanks. Well, there was heaps of things that I had to learn as a part of my job, and solid was one of them. And but I feel when you graduate from school, you do and you start your first job, people don't expect a lot from you, so it's a lot easier for you to learn a new concept on the job. So, but yeah, I had to learn solid out of school. All right, so the next is, for someone wanting to get started to learn solid, what would be some good resources to get started? It would be Tim Corey's blog. His videos are a bit long. I think they are 5.5 hours in total. But they're good, and I do recommend that you have a look at them. I saw them twice or thrice on 2x speed on YouTube. You can do that, or you can watch them once at normal speed. How does dependency injection work? There are many different ways for dependency injection to work, and if you type this question on Google, there'll be heaps of different answers. But I could talk about this, but this presentation was only to give you a bit of familiarity with solid principles and not about how they actually work. So I suggest that you could look at Tim Corey's videos again for dependency injection, and there are some good implementations there. Is that it? All right, perfect. Thank you so much. I hope you learned something good, and I hope you get to use solid when you start your jobs and your careers. Thank you so much for listening. Have a good evening.
Thank you so much for coming, everyone. Here are the links for our Facebook, Meetup, and Slack channel.